Good afternoon. Today I will present the slope stability solution using the Swedish slip circle method. The materials we are gonna use are graph paper, calculator, pencil, compass, rulers, and a protractor. Step 1. Draw the slope and the failure circle. We draw the slope profile using this information. The height is 40 meters, the depth is 50.4 degrees, the cohesion is 50 kilopascal, the friction angle is 30 degrees, the specific weight is 25 kilonewtons per meter cubic, and the radius is 40 meters. It's important the scale value. The scale is 1/250. It's important that the circle intersects the slope to define the sliding area. Step 2. Divide the sliding area into slices. We divide the sliding area into slices. We recommend a minimum of 5 slices for greater accuracy. In our case, we used 8 slices, 2 centimeters in each one. Step 3. We draw the mid-ordinate of each slice. Then we extend this ordinate vertically to draw the weight force vector. Now we draw a line from the center of the circle to the intersection between the mid-ordinate and the edge of the circle. This is the angle alpha. We repeat this process for each slice. We have this graph and these alpha angles.
Some considerations to know is how to get the shear force and the normal force in each slide. We got them by summing the force in a x-axis force and y-axis force. Also, we need to transform the measurements in centimeters to meters using the scale. For example, 1 centimeter is 2.5 meters, and for the volume calculations we use 1 meter wide.
4. We create a table with the following data for each slice. We measure the mid-ordinate and the width, initially set to 2 centimeters for each one. Since the measurements are in centimeters, we use the scale to convert them to meters. Next, we calculate the volume by multiplying the mid-ordinate by the width. Then we calculate the weight using the specific weight and the volume. We also need to measure the angle alpha previously drawn. With this value, we calculate the normal force, that is weight multiplied cosine of alpha, and the shear force, that is weight multiplied sine alpha. Complete, we sum all the normal forces and all the shear forces. We calculate the length of arc, which is the length of the slip surface, using the following formula. In this case, we work with an angle of 90 degrees, previously converted to radians, and a radius of 40 meters. Finally, we use the formula of Helenius to obtain the factor of safety using the data we have already collected. C is for cohesion, L is for length, this is the friction angle, times the summatory force of the normal forces minus this factor that is 0 because in this case there is no water. All this divided into the summatory of the shear forces.